to solve multi-step word problems using a new linear model called strip diagrams. The first thing I want to make sure everyone understands is how a strip diagram works. Because it is a linear model, a lot of students think it has to be just as precise as a number line, which is a linear model that we've already covered. But the great thing about strip diagrams is that you actually get to decide what the length of your paper represents. So it gives a bit more freedom, and you get to because you get to decide everything about how the length represents whatever numbers you need it to represent. So let's apply this knowledge to our word problem. And we've already worked with multi-step word problems and solved them using other models and other types of linear models, but let's use this one and solve it using a strip diagram. So this problem says Susie has 5 necklaces and Jane has 10 more than Susie. If Jane gives 8 of her necklaces to her friends, how many does she have left? So we know that Susie has 5 necklaces and Jane has 10 more, but then Jane gives 8 away. So we know that in order to decide what type of problem type we're going to use, we need to first look at is there an action happening. And we can see in the second part of the problem, the second step, that Jane is giving 8 necklaces away. So she is taking 8 away from her original amount. So we need to think about, we know there's an action happening, and we know if there's an action happening, it's either a join problem or a separate problem. But a join would mean she was getting more necklaces. Is she getting more necklaces? No, she's taking necklaces away. She's taking them away from her original amount, making it a separate problem. But before we can figure out that part of the problem, we need to look at the beginning. And there's no change happening here. But we know that Susie has 5 necklaces and Jane has 10 more than Susie. Is this a part-whole problem? Or do we have 2 amounts that came from the same whole? No, they're 2 separate people and they have their own necklaces. So this must be a compare problem because we're comparing Jane's amount of necklaces to Susie's. So let's look at our problem type for our strip diagram for our compare problem. So we know if our problem type is compare, we need to look at this certain type of model. So we can see that our larger amount will go on top while our smaller amount goes on the bottom, and this empty space will represent our difference. Let's look at our problem and try to see where we're going to plug these numbers in. Well, Susie has 5 necklaces and Jane has 10 more than Susie. Well, we can see just based off that Jane has the larger amount of necklaces. So her number will go on top, while Susie has 5 necklaces, which is the smaller amount, and 10 more represents our difference. So I'm going to go ahead and get out a new piece of paper so that I can show y'all how exactly we're going to work out this problem. So I'm going to say that this piece of orange paper, or a piece of this orange paper, is going to represent Jane's amount of necklaces. And again, I can cut this into whatever length I'd like to represent Jane's. And I think that this looks like a pretty good length for the amount of necklaces Jane's going to have. But I don't know what I'm going to label it yet because I haven't gotten that far. So we're going to go ahead and take this strip of paper and glue it down to our white paper. So this length of orange paper will represent Jane's necklaces. And just like it has up here, we're going to go ahead and draw our and we're going to label it X because it is our unknown for this part of the problem. And we know our smaller amount is going to go on the left side. So we know our smaller amount is going to be 5 necklaces. We need to make a paper that represents the length of 5. I think that this piece of blue paper, this length of blue paper, is going to represent Susie's 5 necklaces. So we can glue this piece of paper down as well. We'll glue it right here where the smaller amount goes, just like up there. And then we draw our lines again. And we're going to label this as 5. This length of blue paper represents 5 necklaces that Susie has. And we know that this area needs to be our difference, and that's going to be 10. So the next thing we need to look at is if this piece, this area, this length needs to equal this same length, we have a formula we can use, and it's going to be smaller plus difference equals larger. And in this case, our larger is represented by x. So our smaller number is represented right here by this length of blue paper as 5 plus our difference, 10, equals x. And we're going to use counting on to find our answer. And so if we add 5 to 10, we know it's 10, 11, 12, 13, 14, 15. Our x equals 15. So that means this length of orange paper now represents Jane's 15 necklaces. Awesome. So we can use this information to move on to step 2 of our multi-step problem. It says if Jane gives 8 of her necklaces to her friends, how many does she have left? So we now know that Jane starts off with 15 necklaces and then she gives 8 away. Well, we already figured out earlier that because she's giving necklaces away, there's an action happening. And we know if there's an action, it either has to be join or separate problem type. She's not getting any necklaces, she's giving them away, so it must be a separate model or problem type. So let's look at how we use a strip diagram to represent a separate problem type. And we have this right here. This long piece at the top is going to represent our start or a starting value. This length down here will be our change, and this empty space will be our result. So let's see if we can figure out what that looks like on our paper. Because this is a multi-step problem, we want to make sure there is some consistency from one problem to the next. So because I'm working with Jane's necklaces still, and up here the orange represented Jane's necklaces, this length of orange paper represented her amount of necklaces, we are going to use that same orange paper to represent it in the second problem, or the second part of the problem. And it doesn't have to be the exact same size. We just want to make sure that it's, roughly the same size, and that looks about good to me. So now we are going to glue down our starting value. So in this case, it is our 15 necklaces that Jane is starting off with. And we'll draw our line. And we can go ahead and write 15 up here this time because we found that value in our first step of this problem. And we know that she is giving 8 of her necklaces to her friends. So we are going to use the subtraction model, which is we're going to use our separate problem type. So one thing to keep in mind is when you are subtracting or counting backwards or reverse, you are going to put your change or your area that you do know on the right. But if we were using the addition model, we would put it on the left. But we'll keep it on the right, just like we have right here, because we are subtracting. We are taking away. And because we use the orange to represent Jane and the blue to represent Susie, we're going to use a new color to represent the necklaces that she is giving away. So we're going to go ahead and just cut a piece of paper. And we know that 8 is about a little over half of 15, just from our number knowledge, what we can pull from our files that we've already created in our heads. So let's see, I'm going to say, I need to take a little bit off that, I think. we're going to say that this amount is going to represent our 8 necklaces that Jane is giving away. So we can go ahead and glue that down. And this is going to be over here for our change, because she is giving those away. Let's draw our lines. And we can go ahead and write 8 down here because we know that she's giving those away. And this is going to represent our difference. So for this part of our problem, our result will be our x. And we can draw the arrow just like we have up there to show our change. We're moving that way. So we know this length of orange paper represents 15. This length of yellow paper represents 8. So for this type of problem, or this problem type, we have a different type of formula. For this one, we are going to have our starting value minus our change equals our results. So just like I said, we're going to use reverse counting. So we know our starting is our 15, represented by this length, minus our 8, represented by this length, equals our result, or our x in this case, right here, this area. So if we do 15 minus 8, and we use backwards counting, we know that we get 7. Because if we go 15, 14, 13, 12, 11, 10, 9, 8, 7. 7. So we know that she ends up having 7 necklaces left. So let's look at our problem one more time. Susie has 5 necklaces and Jane has 10 more than Susie. So we found out that Jane had 15 necklaces. And then Jane gave 8 of her 15 necklaces to her friends. We wanted to know how many she had left, which came out to 7. Jane has 7 necklaces left. Next time, we will go over some different problem types using this new model of a strip diagram.